Hello everyone, in this video we're going to look at the probability of independent events. So, what are independent events? Let's break this down first. Let's say we're playing the game of checkers. You have red pieces and you have black pieces. Let's say I was going to randomly choose a checker, put it back, and then choose again. The probability of getting a red on either one of those picks is 1/2, or 50%. The first pick, or the first event, does not affect the second event. That is what we mean by independent events. Independent events are events that do not influence one another. The impact of the first event does not affect the outcome of the second event. So what does this look like? If A and B are independent events, then the probability of event A and event B is going to be equal to their product. So what we're doing here is we're going to calculate two probabilities and we're going to multiply those results together to get that probability of that independent event. Here's another example. Suppose I had a fair die that was red, and suppose I had a blue one. Two different colored die, and they're both fair. They had the numbers 1 through 6. Suppose I roll the red one and the blue one at the same time. What is the probability that I will roll a 4 on the red cube and then an odd number on the blue one? What does that look like? Let's calculate that probability. So the probability of rolling a 4 on the red one multiplied by the probability of an odd number on the blue one. These are independent events because the outcome of this event has no effect on the outcome of this event, two completely different things. So the probability of rolling a 4 on the red one, that's 1 in 6, multiplied by an odd number on the blue, well, that's 3 out of 6. I'll go ahead and reduce this to 1/2 to make the product a little bit easier. This will be 1/6 times 1/2, which simplifies to 1/12. And that's it. That's how you calculate the probability of independent events. It does help if your fractions are in lowest terms to make that final calculation a little bit easier. Let's try another example with the colored die here. Let's say I want to roll a 5 on the red one, and then on the blue one, let's say we'll roll either a 1 or a 2. Well, this probability is still 1/6. A 1 or a 2, well, there's one of those and there's one of those, so that would be 2 out of 6. Because there's exactly 1 1 and 1 2 on a fair die. Multiply these two together, change this to 1/3 to make it a little easier. We're doing 1/6 times 1/3. And that gives us 1/18. So it is possible, it's just that the probability is very small. This is very, very small. It's way less than 1/4. Let's look at one more example. Here we have a bag that contains vowels. We have 4 A's, 3 E's, 2 I's, 4 O's, and 2 U's. You choose one of these tiles at random, replace it, and then choose again. What is the probability that you choose an A and then an E? The key to this problem is right here. Whenever you deal with a probability where you're looking at a problem that says with replacement, that is key for independent events. So we're looking at choosing an A and then an E with replacement. So independent probability, 4 plus 3 plus 2 plus 4 plus 2, that's exactly 15. So the good news is that both of our denominators for this calculation will be 15. There's exactly 4 A's, and there are 3 E's. This gives me 12 out of 225. This can be replaced because both of these numbers are divisible by 3. In lowest terms, this is 4 over 75. So again, a very small probability, but it is still possible for that to happen. And again, replacement is the key for letting us know that this is an independent event. Thank you so much for watching, and I will see you later.